Factor completely and find zeros. This is really just more examples, and these could be written several different ways. So I'm going to kind of do the same problem different ways. Not do them different ways, but kind of show you different ways they could be asked. So as long as you understand the vocab, it's not that different. And obviously I didn't put vocab and questions on here, so this is really just extra examples. You can write a little summary, but it's nothing really different than before. So here's a polynomial function. I could ask you the same question in two different ways. I could ask you to factor given that one factor is x plus 14, in which case I'm going to look for the other factors, and there's a few different ways to do that. Or I could ask you on the same question to find the zeros given that negative 14 is 1, 0. Notice on one I gave you a factor and I asked you to factor, and one I gave you a 0 and I asked you for zeros. Notice that this factor would mean that this is one of the zeros. So I'm going to do synthetic substitution or division, whichever way you want to think of it, based on what I was given. So I'm going to use negative 14 because no matter what I'm doing, I'm using the 0. There's no missing terms in this one, so I've got 1, 11, negative 150, and negative 15, 12. So I'm going to bring down my 1, negative 14, negative 3, positive 42. Let's see, 42, so it'd be negative 108. I'm going to do this math off to the side. 108 times 14. Oh look, conveniently it's 1512. Now I knew that sort of because it said I could factor it. If it was going to be factorable, I'm going to get a 0 here. That meant that my original thing was factorable. So now, what is this thing I got? Well, this thing I got is x squared, because I had x cubed divided by x, minus 3x minus 108. And I could, if it's factorable, I have to really factor it. But again, I could use division again, trying with guessing and checking what some of the zeros would be, just because you've seen how trinomials factor. Or I can just go ahead and factor. And this one, it's again with a coefficient of 1. I hope you start to kind of see some of the shortcuts. I know it's going to be a positive and a negative, so I'm just going to do the t-chart here, looking for things that multiply and give me 108 and add up to negative 3. 1 and 108, 2 and 54, 3 and 36, 4 and 27, 5, 6, 6 and 72, and that's not right, 6 and 18, and 9 and 12, and it's going to be 9 and 12. So 12 is going to be negative, 9 is going to be positive. So if I asked you to factor, give me the factors are x plus 9 and x minus 12. That would be my answer if I was asked to factor it. If I was given the very same question but asked to find the zeros, my answers would be negative 9 and positive 12. I could be asked to factor, given that x minus 8 is one of the factors, or I could be asked to find the zeros, given that one of the zeros is 8. So again, I see I can do synthetic here, no problem. 15, negative 1, 19, negative 10, 16, no missing terms. Let me use 8. 15 times 8, it's 80 and 40, 120. So that's 1, that makes things nice. So 15x squared plus x minus 2. And again, that's going to be factorable. Because they told me I could factor it, if they had asked for the zeros, I wouldn't necessarily know. And I could use the quad formula from here if I was just asked to find the zeros. But since I'm telling you it's factorable, we'll go ahead and say, looking for things that multiply and give me negative 30 and add up to 1. So that's going to be 5 and 6 with the 5 being negative. So 15x squared, negative 2, negative 5x, positive 6x. This is going to be 2, 5x, 3x, and negative 1. So it factors to 5x plus 2, 3x minus 1. So if the question was factor, then the answers would be 5x plus 2 and 3x minus 1. If the question was find the zeros, then I would have to set those two little guys equal to 0. Okay, and I would do the same thing on the other one, and I would get positive 1/3. I'm not going to show the work, but my two answers on this one would be negative 2/5 and positive 1/3. I could use the quad formula if I was asked to find the zeros, but if I'm asked to factor, I've got to factor, and I've got to still be good at factoring. One more example that it's not going to be factorable. So I'm just going to have to be asked to find the zeros given one of the zeros is 9. So x to the third minus 9x squared minus 5x plus 45. So 9 is a 0, 1, negative 9, negative 5, 45. Not missing any terms, didn't need any zeros. Bring down the 1, 9, 0, 0, negative 5, negative 45, 0. Okay, now I was told it wasn't, basically I wasn't told it wasn't factorable, but I'm kind of telling you that it wasn't factorable. Well, what do I have here? X squared, there's no x term, x squared minus 5. So that's the other factor. So if I was asked to factor, it would be that and I would be done. But that wouldn't get me all the zeros. So if I wanted to find the zeros, I have to solve this little equation. I can't factor that. I could put it in quad formula, but again, remember, it's way easier when you have this kind of thing to just take the square root of both sides. Don't forget your positive and negative. So my answers are going to be positive and negative square root of 5. So you're not going to always have nice pretty numbers. You might have radicals. We'll get down to it. You might have i's. I don't think you have any today. But radicals are fair game. So those are the two of the zeros besides the third zero that they gave you to start with.